Many Python programs need to use arithmetic, and Python provides some symbols for us to do that with. So I'm going to open up a command prompt, and I'm going to start my Python interactive interpreter by just typing Python. Make this a little larger so it's easier to see. And so let's take a look at addition. So for example, if I say 5 plus 7, I get 12. You can also, let's do 3 plus 4. Whether you put spaces around the plus or not, it doesn't matter. Python will figure out what the numbers are. But basically, just addition is just using the plus sign. Subtraction works the same way. Just put the symbol between the two numbers, and it will do subtraction. If you subtract a larger number from a smaller number, you'll get a negative number. And in addition, you can use multiplication. Now for multiplication, the symbol is going to be the asterisk. The asterisk represents, we wouldn't do this, for example, because later on we'll find that variable like a symbol like x will be used, could possibly be a variable. So the symbol that's used for multiplication in most programming languages is a asterisk. You can also multiply, by decimal value, and that would basically divide that in 2 by multiplied by 0.5. You can also do division. Division is the / symbol, and if I divide 77 divided by 2, I get 38.5. If I divide 88 by 3, I get 29.333 repeating. And so repeating characters will basically go out to a large range, and then it will round off the results at a certain point. So often these floating point numbers are only so precise. They can't be infinitely precise, obviously. You would need an infinite amount of memory to store that. So it will truncate and round off the number at a certain point. So that's division. Another type of division that Python will do is integer division. So if I divide 5 divided by 2, normally that would be 2.5. However, if I do a double slash, notice that I get 2. And so this is integer division. Basically, when you do integer division, it will drop any decimal point value. So 7 integer division 5, for example, will be 1, because 5 goes into 7 one time with 2 remainder, and it just drops whatever's left over. 11 divided by 3 would be 3, whereas 11 regular division by 3 is 3.666 repeating. So sometimes we don't want the remainder, we just want the integer division. So we have that option. Now, let's say that you wanted the remainder. So if I were to take 5 divided by 2, I would get 2. The remainder would be 1, because 2 goes into 5 2 times and it has 1 remainder. Well, we can use the modulus operator to get the remainder. So here, 5 modulus 2 results in 1, which is the remainder. If I were to do 7 modulus 2, again, I would get 1. If I were to do 9 modulus 5, 5 goes into 9 one time with 4 remainder, and so I get 4 remainder. And this operation is often useful if we want to see if something's evenly divisible. So if we want to see if 22 was evenly divisible by 2, we would, if it is, it'll return a remainder of 0. If we have 88 modulus 4, does 4 go into 88 evenly? It does. So a lot of times we'll use this to see if a number is evenly divisible by another, and we'll just test to see if it returns a 0. Then the next thing is exponentiation. Can we raise if we want to raise a number to a power, so 10, if we put a double asterisk, that doesn't mean multiply, that now means raise to that power. So this is 10 to the second power, and so we get 100. 3 raised to the second power, we'd expect that to be 9, and we do in fact get 9. You can also, let's see, what would happen if we raised 100 to the 0.5 power? So 100 raised to the half power, it's actually 10. So you can actually use that for square root if you wanted to, is just raise it to the half power and you get the square root of 100. So those are our fundamental arithmetic operators. We have addition, we have subtraction, we have multiplication, we have division, and we can, with division, we can also get decimal values. We also have integer division, which doesn't include the decimal part. And then we have the modulus operator, which gives us the remainder. And then we have exponentiation. 3 raised to the second power gives us, that's 3 raised to the second power, 2 asterisks, gives us 9. And then we can also raise to 0.5 in order to get a square root. So those are the fundamental arithmetic operations. Thank you.